Okay, so my name's Becca Price. I am here from the University of Pittsburgh. I'm a clinical psychologist by training. I just want to start by expressing really sincere gratitude for inviting me today. I was really blown away when I got an email from Rupert and Sarah. It must have been within days of changing my clinicaltrials.gov status of recruitment to completed. I mean, it might have been within hours. And I got this email saying, do you think you'll have something ready for Ketamine 2022? And I said, I hope I'll have something worth saying. So here I am. So I just really am amazed by the effort that's been put in to create this community. And it's a privilege to be a part of it. All right. So my disclosures, I have for the first time an actual disclosure, something I've never had before, which is that I am named as the inventor on a provisional patent that was filed by my institution relevant to what I'll be presenting on today. And the funding for what I'll present on is from NIMH. So my project was inspired by two threads that have both been part of my research program for some time now. I don't need to belabor the exciting elements of rapid acting antidepressants when those came on the scene, and in particular intravenous ketamine, which we all are here to talk about. But the other one for me is the potential of automated computer-based treatments to potentially radically increase patient access to care and reduce costs, minimize burdens and aversive consequences. And my project that I'll describe is really aimed at attempting to synergistically combine the advantages of both of these approaches and create something that's both rapid and durable. So the study in essence is about reframing ketamine's impact as a short-term plasticity boost for learning to facilitate uptake of new learning. So I'm speaking about neuroplasticity really in a conceptual framework as a broad umbrella term. Of course, we've already heard a lot about the nitty-gritty and all of the complexities of what that actually means, but I am interested in this idea that the brain's capacity to flexibly adjust and reorganize itself in response to our ever-changing environment is somehow enhanced by ketamine. And so, of course, the classical findings from this literature, as Chadi outlined very beautifully in his 2015 review, have shown that in animal models, if you expose to chronic stress, you'll see a withering away of some of the points of contact, some of the spiny synapses on dendrites in key regions implicated in affective regulation, like the medial PFC, and in limbic areas like the hippocampus. And the idea is that depression and other psychological states involves this synaptic disconnectivity, and that recovery from depression and the treatment target is about repairing that deficit. But as a psychologist, I'm really fascinated by how that might map on to the types of things that patients describe when they tell us about how they get stuck in a limited space of options and just can't see a way or actualize a way to have a more flexible behavioral approach, a more flexible cognitive thought patterns in response to their environment. So in my research program, I've been working from this kind of conceptual framework regarding this construct of neuroplasticity and how it might apply to a wide range of psychological conditions and kind of how it might propagate up the system at different levels of analysis, manifesting, for example, as disrupted function and connectivity within prefrontal and limbic circuits that we might see in fMRI measures, and also in the information processing patterns, such as part of what Emma had touched on earlier in her talk, these rigid negative biases that we can see in patients when it comes to attention, memory, the way they represent themselves and their self-attributions, decision-making, and more. All of these kind of show these negative and kind of stuck patterns. So that then gives us an understanding of how an individual who enters each and every environment with that sort of framework and this way of processing the information available in the environment might then yield affective states and the patient-reported symptoms that we see chronically in these conditions. So I had the great privilege to work with the late, great Ron Dumont on a 2020 review paper where we tried to outline how this might all be sort of different pieces of the same puzzle. But what I'm most interested in is to use this as a roadmap to creating novel strategies that get people well quickly and hopefully keep them well over the longer haul. And so over the past 10 years or so, I've been drawn to focus on integrative or synergistic treatments, where the idea is that we might get a stronger or more efficient and more enduring positive impact by tackling multiple levels in this process simultaneously. So in my lab, we've been using multiple methods in an effort to open a window of plasticity. So some of my studies, we use transcranial magnetic stimulation to do this in a more localized focal way. But in the studies I'll describe today, we've used intravenous ketamine and then tried to inject into that window of opportunity useful opportunities for learning and skill acquisition that we think will be protective over time against the return of symptoms. So in terms of ketamine's rapid impact as a standalone treatment, of course, we've heard many of these studies, and including the very seminal work that showed us these effects. But if we fast forward about 20 years now, we are recently in the late stages of compiling together all the data at the individual patient level that we can get our hands on for every RCT that's been done over those past 20 years, where a depressed sample received either ketamine or some sort of placebo. So working with statistician collaborators in my department, we've gotten analyses on 17 RCTs conducted in 8 countries over 4 continents, and we can really leverage this individual level data in a way that's not possible with standard meta-analyses where you have 1 data point per study. Now we have 1 data point per patient in these 809 patients. This would be a whole nother talk that I'm not giving today, that I'm not signed up to give today. So I'm just really just highlighting that overall this response rate of 46% is what we're seeing overall in these 17 RCTs, 27% remission rate. So this is kind of where the field now lies in terms of the overall efficacy that we see at the rapid time point. And this is one example of a moderator that we've identified through this approach, because we are able to look very exhaustively within this data set for the characteristics that might enhance the effect, the differential impact of ketamine versus placebo. And this one that I'm highlighting here is that higher levels of treatment resistance are actually associated with greater differential effect of ketamine versus placebo and across all of these RCTs. Although both groups do show separation from placebo, I should say. Okay, so if we think of neuroplasticity as being what we want to target, we have some very interesting animal neuroscience data that's been around for quite a while now, looking at how ketamine might induce these rapid synaptogenic effects in the medial PFC. So that you see, starting from the effects of chronic stress here on the left, if we see the synapses reduced by that stress here in the middle and then rapidly restored 1 day after an infusion of ketamine. A more recent paper from Moda Sava in 2019 used a really interesting optogenetic approach where after seeing this sprouting, this regeneration of synapses following ketamine, they were able to optogenetically selectively delete just those synapses that had been sprouted by the ketamine. And when they did so, they saw reinstatement of depressive-like behavior in at least one of their behavioral tests. So just showing the importance of these synaptogenic processes. So much of this insight comes from animal studies. And I think that we still have so much to uncover with respect to how these different pieces of the puzzle might actually all fit together. And so this was one of the goals of the R01 that I'm describing today, was to kind of think about this and collect information very integratively across a number of levels. It's a really mountainous trove of data that we're just taking the lid off of. So I'm only talking today about very briefly touching on just one of the indices that we've collected, which is what I think of as being the closest thing that we have to those animal studies that I just described in human patients. And this is a measure you can get from diffusion weighted imaging. It's called mean diffusivity, and it quantifies, usually DTI we think of as being useful in white matter, but you can use it in gray matter to look for microstructural changes that might reflect things like the sprouting of new little synapses on those dendrites. And so previous animal work had used this approach and showed that you can find these microstructural changes within limbic regions like the hippocampus after training animals in a relevant paradigm. Just 2 hours later, re-image them. You can see these changes in the mean diffusivity marker that are correlated with other neuroplasticity markers like synaptic vesicles, astrocyte activation, BDNF expression. So it suggested we can localize this neuroplasticity in vivo over short time scales. And in humans, one of my collaborators, Tim Keller, used this measure in a study where half of the individuals were given a 45-minute training session in a spatial learning kind of maze game and scanned before and then just after the training. And this, in the group that received the training, this measure picked up on what the authors interpreted as the sprouting of new microstructure or synaptic connections that represents that learning that they just gave them within that 45-minute window, whereas the control group doesn't show this. And you see these are the marker of mean diffusivity is always going to be inversely related to kind of the density of microstructure in the region. So in our study, we had 154 unipolar depressed patients. They had to have failed one FDA-approved antidepressant. They were able to continue concurrent antidepressant treatments. They had to have a baseline MADRS score of 25 or greater. And in this study, they were randomized in a 2-to-1 scheme to receive either a single infusion of ketamine using the standard protocol or saline. So with a really talented and wonderful postdoc in my lab, Jared Kopelman, we've been looking at this mean diffusivity marker in relation to treatment outcomes in our study because we have the measure at baseline and then again at 24 hours. So this is showing the change from baseline to 24 hours in the mean diffusivity versus QID scores. And so what we see is that in the ketamine group specifically, changes in this marker of microstructural density in the left medial PFC here and in the left amygdala are tracking positively with symptomatic outcomes following ketamine. So the more of this kind of density sprouted up, the better the patients are reporting that they're feeling. And similar effect in the right medial PFC as well. So right in these regions that have been so heavily implicated in the animal literature. Now, there's a caveat that we do not see these types of patterns in every region that we've looked at, including the hippocampus. We're not seeing this type of effect there. And we also are not seeing a main effect of ketamine versus saline on this marker. So it's really about the individual differences. Am I doing that? Okay. So that's a peek at one of our levels of analysis. Now I'm actually going to back up to some earlier work that we've done where we tested how ketamine might impact things at this information processing level, and specifically the idea that ketamine might rapidly loosen up and allow a patient to get kind of unstuck from rigid negative biases pertaining to their own self-worth. So for this, we've used the implicit association test, or IAT. So you can see in this example here, in this particular study, we were interested in suicidal cognition. So we looked at associations between oneself and suicide-related constructs like escape. And so in this sample, the patient must press the left key if they see a word in the middle that's either related to me, myself, or to escape. And then in other blocks, we swap the pairing so that now they need to press with the same key for me words or for stay words. And it's the differential between performance on those two blocks and the speed of performance that gives us a behavioral performance-based index of how tightly associated in the mind two ideas are. So we had shown all the way back in 2009 in a very, very small open label study where we first described the impact of ketamine on suicidal symptoms. In that same study, we also used the IAT and found this rapid drop at 24 hours post-ketamine in the strength of association between escape and me. And this association, the performance on the IAT, as well as on a death equals me IAT, both were correlated with the degree to which suicidal symptoms were reported as being decreased following ketamine. So this was really, really small sample, but later we did replicate this in a RCT, much larger sample with a midazolam control, and found that there was a specific decrease in this IAT measure of self-associations in the ketamine arm. So this led us to a hypothesized window of opportunity in thinking about targeting self-associations and opening up plasticity within self-associations. So if we think of depression as involving this sparsely connected network where maybe you have a lot of really well-trodden pathways for things like self-loathing, but you don't have a lot of different avenues that get you from me to good or worthy. One way that I think about what we do in cognitive behavioral therapy is kind of piece by piece, painstakingly building those types of roads. But I think of ketamine as kind of airdropping in a whole bunch of bits and pieces of road very efficiently and rapidly. So this might create a window of opportunity where we can then kind of practice and strengthen and traverse the pathways that we think are antithetical to depression, and hopefully activate a protective and enduring system state through kind of allowing experience-dependent plasticity mechanisms to kick in and retain the most important pathways. So that was the crazy idea that we tested in this recently completed RCT. So we used to kind of go after these self-associations. We used different paradigms from this evaluative conditioning realm, which is something that's been studied for many decades, but mostly in the social psychology and sociology realms. But essentially, you just can take any unconditioned stimulus. Most often, this is positive stuff like positive images and words, and a conditioned stimulus. In our case, it was a self-relevant stimulus, and just repeatedly pair it with a very simple kind of Pavlovian conditioning paradigm. And you can show that this actually impacts liking and preference. And this is exactly what advertisers are doing when they're repeatedly pairing their product with smiling faces of beautiful people and trying to make you like their product. So there were some studies to suggest a hint of possible clinical potential, but little had been done in the realm of kind of full-fledged clinical trials. But we thought maybe this would be a synergistic match for what ketamine is opening up, the window that it's opening. So we drew several paradigms from this evaluative conditioning literature. So this one is Lexical, our Lexical version, and we gave it in both a subliminal and superliminal form to every patient. They all got both. So essentially the conditioned stimulus is the letter I standing in for oneself. And then it's just flashed briefly, then a positive word is flashed briefly, and then there's some sort of incidental task just to keep people engaged with what's happening on the computer screen. And the very nice thing about these types of interventions is that you have a really strong built-in sham version that you can make where the patients are doing the exact same thing, but just without the therapeutic content. So in this case, we flashed the letter X, and then paired it with neutral words in the sham version of training. They're still doing the exact same type of task over and over again. The other version that we also gave to every patient was a pictorial version where we actually took photos of the patient themselves and then displayed them at random, flashed them onto this 2x2 grid. They had to click as fast as they could on their own image. And then as soon as they do so, it's replaced by a photo of a smiling face from a standardized set. Whereas in the sham version, they were clicking on photos of a gender-matched stranger, and it was followed by different types of facial stimuli, including mostly neutral stimuli. Okay, so in our RCT, patients were randomized 2-to-1, as I mentioned in describing the DWI findings. So the reason for that is that the ketamine group was further split in two. So here what you're seeing is just the effect of ketamine at 1 day after infusion. That's this larger dip here that you see at day 1. So everybody got either a single infusion of saline, which is the blue group, or a single infusion of ketamine, which is the gray and orange group. Then so this corresponded to a 52% responder rate in the ketamine group, so very much in line with what we had found in the mega-analysis as well. So the next, after that first day, they began cognitive training, which consisted of 30 minutes or so total a day for 4 days of playing this computer game and nothing else. So then we followed them for a month, initially getting our clinician rated primary outcome. And we found that the group in orange, which got the ketamine plus active cognitive training, is now being compared to those who got ketamine plus sham training in gray, or those who got saline plus active training. So it gives us a control group both for those who get the behavioral component without the drug and those that get the drug without the behavioral component. And so what we see is these very parallel lines characterized by a main effect with no interaction effect over time, between the blue line, the saline group, and the ketamine plus active group over the entirety of the 30 days. And this is a moderate effect size. Whereas in the group that got ketamine with the sham training, you see what you typically expect after a single infusion of ketamine, where they're just over the ensuing weeks, they're gradually kind of dipping back up. So this is encouraging, and we are conducting a naturalistic follow-up for an entire year. So after that, patients are going out and, of course, seeking whatever other treatments they want. But so, this is very much still ongoing. So far out to month 3, we're still seeing, sorry about the color schemes switching up on you, but in our self-reported measure, which we're collecting during this window, we see that the green line, which is the active group, is still looking better than both of the comparator groups over out to 3 months after this very short intervention that we gave. So I'm fortunate to be partnering now, as I mentioned at the onset, with the Innovation Institute at my institution, who have incredible expertise in trying to see how we can find a pathway from a research innovation to something that, in my mind, hopefully actually can get to providers and patients. And they have expertise in this, which I certainly do not possess. So they're partnering with me in seeing if we can get this all the way out there, because I've seen so many interesting ideas that kind of echo within the academic sphere and don't get out there. So the first step, the milestone that we've reached, is to file this provisional US patent on these methods and systems for neurocognitive training following a drug administration. So it'll be an interesting adventure to see where it leads from here. Another future direction is that we are now embedding this entire kind of model of intervention into a very real world setting, and trying to use it to address one of the most pressing clinical needs, which is reducing suicide risk among very high risk patients. So what we're doing is recruiting inpatients who have just had a medically serious suicide attempt during their inpatient stay. During the phase of medical stabilization, they already typically have an IV in. We can very easily give them a ketamine infusion in that setting. And then when they proceed into standard psychiatric inpatient, we can meet them there with our web-based app and give them the cognitive training. And so we're testing, this is all hypotheses at this point, but we're testing whether the combination of ketamine with the active cognitive training might create an enduring impact even on suicidal behaviors or other kind of high risk outcomes. So in a pilot, we showed just as a kind of proof of principle that those very same rapid effects on suicidal ideation that we've seen so many times in the research context in depressed outpatients can be found as well following an infusion of ketamine in this medical setting with these very heterogeneous patients who include some of the most difficult to treat patients, like those with very repetitive suicide attempts, those with active forms of suicidal ideation, and with critical comorbidities, including addictions. And our version that we're using now for this study as well, it includes all the components I showed from the previous study, but we've also tried to enhance it a bit with some new paradigms. So this one shows my daughter, Juliet, standing in as for a photo of the patient. So this would be you as a patient, and you're asked to memorize associations between your self-related images or words and stimuli that are positive, stimuli that are related to life, as shown in this growing plant as an example. And then this is more of a distractor, kind of just a filler item. And then you need to select the correct match from this kind of matrix. So it comes across as a memory type of game, but really the whole thing is rigged because every single item in this matrix is either self-related or positive in the active version. And then the sham version is just the same exact game, but with all the pairs being neutral-neutral combinations. And so since this is a very real world kind of deployment focused study, we're interested in measuring the satisfaction, acceptability, any barriers or facilitators to uptake from both the providers and the patients. And so we're encouraged that so far we're getting very, very high acceptability and satisfaction ratings from our patients, so around 80% or higher for both the ketamine infusion procedure and for the cognitive training procedures, even though they're sort of boring. Patients are giving us positive feedback. And in spite of everything else that these patients have ongoing in their life at this point following the suicide attempt. And I also am encouraged that when we split our sample according to whether the patient is from an underrepresented minority, racial or ethnic group, we can see that the acceptability ratings and satisfaction ratings remain high, which is important to me and encouraging to me, as one goal that I have is to develop delivery models for treatments that are so portable that they could be used in a wide range of community-based settings, serving where our under-resourced communities in the highest need. So, oops, this is all of the many, many shoulders of people that I'm standing on, and this is only just for the suicide attempter study. This is the team for that study alone. Here are some of my other key collaborators throughout my career that I wanted to thank, and thank you for listening.
Thanks very much, Becca. That was really fascinating. I can already see there's a few questions. So yeah, maybe we'll just take a couple. Yeah.
Are you exploring either repeating the cognitive training later in a block or continuing it, seeing the effect of the boost to at least dissipate a little bit?
Yeah.
Tried that yet?
Not yet. Yeah, the second study in the suicide attempters, we got funding for that before I actually had the results for the first one. So it's very much the same design, but I agree that booster sessions. And so what we did, since we changed it to a web-based delivery model, we give them access to continue to use and kind of self-administer booster sessions. So I'm very curious whether any of the patients will actually do that. We send them kind of just an automated friendly reminder every so often that you have access to this. So that'll be an interesting data point in and of itself, whether patients left to their own devices kind of continue to access this. But yeah, I think it's a really crucial question. Like, this just shows us the tip of the iceberg in terms of whether we can get more bang for our buck here.
Can I ask a quick one first as well? Did the patients know they're in the sham group with the cognitive training?
Thank you. I forgot to mention, they did not. So everybody in every group was, their median was 50%. They did not know whether they got active or sham, and there were no differences between the two groups. So the blinding worked for that. It did not work, of course, for ketamine versus saline, which I expected.
Yeah, I'm going to ask a question along those lines, maybe just following up, because I guess if you're going to do this large scale, the rationale for your intervention will become available, right? So people will know, I've got to take ketamine, and then they're going to reprogram my brain with subliminal messages that they're flashing up to me. And so I guess I was kind of interested if you've thought about just explicitly telling folk, this is the condition. We're going to show you some positive stuff about you, because like some of the stuff in the earlier stuff with training that had slightly complex effects. I think, right? If you instruct participants about the training and whether it might be appropriate.
Yeah. I'm thinking of the attention bias findings where there was a bad effect of the press that some of the findings got because patients learned about too much about the paradigm. Is that what you're kind of alluding to? Yeah.
Other stuff that I'm not sure if it was ever published, but they just randomized people to either just be told what was happening in training or not.
Yeah.
A bigger effect on their doctoral measure outcome, but then a smaller effect on anxiety. They did it as well. And so I guess yours is a bit, I'm not sure whether explicit knowledge of yours would be a bad thing, to be honest. It might be. But it would certainly make it easier to do repeatedly in the real world if you're going to.
Yeah, that's a really interesting suggestion.
One quick last question from Cigar. Sorry.
Well, first of all, thank you for a brilliant presentation, and especially thank you for doing work with depressed suicidal patients, which most researchers and certainly all drug companies avoid. I'm just curious, with the cognitive training, since you started off with neuroimaging data about what ketamine does, is there any background data that this kind of cognitive training actually through imaging has an effect on neuroplasticity?
Not much, if any. But yeah, I do have, among the mountainous trove I mentioned, we actually get imaging again just after either active or sham cognitive training, and again at day 30 at the last kind of in-person visit that we did. So we will be able to look more long-term. So far, we've just focused on the impact of the ketamine on that one measure. So I have multiple collaborators looking at the different sides of the coin, and hopefully, I really would love to have an integrated story of kind of how all these pieces fit together at the end of the day.
Oh, well, it's time for tea. So thanks again to all of our speakers. And yeah.